Here's a classic problem where they give you the wavelength of a certain type of light and they're asking you to find the amount of energy that is contained both by a single photon of that wavelength and a mole of photons. To figure this one out, we use the combination of Planck's constant and wavelength equals velocity times frequency. So Planck's constant h is 6.63 times 10 to the negative 34th. As the speed of light is a constant in a vacuum, it's 3 times 10 to the 8th meters per second. And then wavelength, they gave it to us as 26 nanometers. Now nano is a prefix that means 10 to the negative 9th. So in this case it's 26 times 10 to the negative 9th. I guess we should include units here. And then the other bit is you have to consider how many photons. So sometimes when I'm writing this equation I like to put a little n, meaning the number of photons of that type. So in part A, or the first problem, the energy contained by that single photon would be 1 photon times Planck's constant times the speed of light all over 26 times 10 to the negative 9th meters. We have to make that wavelength in meters for the equation to work. Now 26 times 10 to the negative 9th is not in proper scientific notation because the first number isn't between 1 and 10, but that's okay. We're going to just use that mathematical quantity to solve, and so it doesn't have to be in proper format. Okay, so we crunch the numbers, pull out your calculator to do this. In my case it works out to be 7.65 times 10 to the negative 18th joules. And then in part B, or the second question, they ask what's the energy of a mole of those same type of photons. You could either, students, if you wanted to, you could just shortcut this and just say multiply this number by Avogadro's number, and you'll get your answer to the second problem. But let's say you didn't have that prompting from the first problem. Then I would say, okay, I have a mole of photons, 6.022 times 10 to the 23rd. I'm going to multiply that by Planck's constant. And multiply that by the speed of light. They give us, once again, the wavelength, 26 times 10 to the negative 9th meters. That's a lot to crunch on your calculator, but once you do it, it'll come out correctly. 4.6 times 10 to the 6th. So notice that in the first part it was a really small number of joules, and in the second part it's a fairly large number of joules, 4.6 million joules.